Welcome to This Explainer. Today, we're diving straight into the absolutely incredible journey of how a totally ordinary, simple block rock from the deep, dark depths of the Earth transforms into a dazzling diamond. I mean, you have to realize, this is one of the most difficult, expensive, and frankly dangerous industries on the entire planet. We're talking about millions of people and billions of dollars involved every single day, all in the quest to find these tiny, sparkling stones. It really is a wild story of intense geological pressure, crazy human ingenuity, and just unimaginable wealth.
Here's a quick look at our agenda for today. First, we'll look at the birth of the diamond. Second, the difficult and dangerous world of mining. Third, extracting those stones. Fourth, rare diamonds and their value. And finally, natural versus laboratory diamonds.
All right, let's jump right into Section 1, the birth of the diamond, looking at deep time and geology. So our journey actually begins millions of years ago, way down below the surface of the Earth. You see, diamonds don't just form near the surface where we can easily grab them, right? They're forged incredibly deep underground, under extreme heat and pressure over millions of years. But here's the cool part. These things called kimberlite rocks basically act as nature's elevators. Massive volcanic eruptions in the distant past blasted these kimberlite formations upward, bringing the hidden diamonds along for the ride and depositing them much closer to the surface where we actually have a shot at finding them.
But honestly, finding these kimberlite pipes, it's like the ultimate needle in a haystack. It's no easy task. Today, geologists have to use advanced satellite imagery and aerial mapping just to survey vast areas for potential deposits. And it isn't just about digging in the dirt. Nature actually scatters these gems over time. As wind, rain, and rivers slowly erode those volcanic rocks, the diamonds are washed away and travel downstream. You can literally find them in riverbeds. In fact, off the coast of Africa, there are these massive, specialized ships that scour the deep ocean floor, dredging up sand and rock, just to find diamonds that were washed out to sea millions of years ago. How crazy is that?
Which brings us to Section 2, difficult and dangerous mining, the scale of human engineering. Once a deposit is finally pinpointed, the sheer scale of human engineering required to get it out of the ground is truly mind-boggling. Setting up a mine is not some quick weekend project. We're talking years of planning and billions of rupees in investment just to build the roads, the electricity grids, and water supplies before a single stone is ever extracted. Take Russia's Mir mine, for example. It's a crater hundreds of meters deep and several kilometers wide. It's so enormous you can literally see it from space. Or the historic Big Hole in South Africa, which was dug out entirely by hand by thousands of workers. The infrastructure is just colossal. Today they're using trucks the size of a multi-story house to move the earth.
And here is why they need those giant trucks. It takes hundreds of tons of rock and soil to be moved and processed just to find a single carat of diamond. You are literally moving mountains to find a handful of stones. And this immense effort, the crazy amount of time, and the real danger, from collapsing rocks to gas leaks in underground tunnels, well, that's exactly why diamonds carry such an incredible price tag.
Let's move on to Section 3, from stones to diamonds, the science of extraction.
Okay, let's step into the processing plant. This is where human ingenuity really shines, separating the precious gems from literal mountains of rubble. Once those house-sized trucks drop off their payload, massive industrial crushers systematically break the boulders down into smaller and smaller pebbles. But think about it. How do you actually spot a tiny diamond in a sea of gray gravel? Well, diamonds have this very specific reaction to light. As the crushed rocks move along conveyor belts, they pass under specialized X-ray machines. When a diamond passes through, it glows. The machine's automated system instantly detects that glow and triggers these incredibly powerful, precise blasts of compressed air that literally shoot the diamond right out of the debris and into a collection bin. It's a lightning-fast, high-tech sorting process.
Now, here is a fascinating twist that most people don't know. Surprisingly, the vast majority of the millions of carats mined every year, they never see a ring or a necklace. Never. Because a diamond is the absolute hardest natural material on Earth, its primary use is actually industrial. They're heavily used in oil and gas exploration, mounted right on the tips of massive drill bits to cut through solid rock. They're in tunnel boring machines and precision cutting tools. Those visually stunning stones that actually get selected for high-end jewelry, they make up just a tiny fraction of the diamonds we pull from the Earth.
All right, Section 4, rare diamonds and their value, art, science, and rarity.
So what is it that makes certain diamonds just astronomically expensive? While we all naturally think of diamonds as clear and completely transparent, nature occasionally throws in a spectacular twist. Trace elements and environmental factors can actually create brilliantly colored diamonds: yellow, green, orange, even black. But the most highly prized ones are blue and pink. A blue diamond gets its striking color from tiny trace amounts of the element boron trapped inside its carbon structure. Pink diamonds, though, they're a bit of a geological mystery. Scientists believe that immense pressure deep within the Earth actually slightly altered the crystal's structure, causing it to absorb light differently. Because these conditions are so incredibly rare, the value of colored diamonds just skyrockets far, far beyond the transparent ones.
3,106. That staggering number is the carat weight of the massive Cullinan diamond, which is the largest rough diamond ever discovered. It was found in South Africa back in 1905, and this single stone weighed over 3,106 carats. Absolutely wild. It was eventually cut into several spectacular pieces, many of which now sit proudly in the British Royal Treasury. It's a pretty amazing testament to the sheer awe-inspiring potential of what the Earth can produce.
But how do we actually value a normal diamond today? Well, specialized laboratories use microscopes and advanced tools to grade every single stone on the famous 4 C's. You've got carat, which is the weight; clarity, which measures the lack of internal flaws or blemishes; color, looking for pure transparency or those ultra-rare hues we just talked about; and finally, cut, which is the expert shaping that maximizes the stone's brilliance and sparkle. The crazy part is, even 2 diamonds that look completely identical to the naked eye can have a price difference of thousands of dollars just based on microscopic variations in those 4 categories. The lab then issues a detailed certificate that guarantees its precise value.
Let's look at Section 5, Natural versus Laboratory Diamonds, the Modern Era. As we bring this whole journey into the modern day, we really have to acknowledge that digging giant holes in the Earth obviously has a significant impact. And historically, yes, there have been massive issues with illegal mining and poor working conditions. But today, major companies tightly track a diamond's journey from the mine to the market to ensure it's legally and safely sourced. Plus, recognizing the massive environmental footprint of mining, which can literally affect thousands of acres of land, the industry now heavily regulates extraction. Modern mining companies focus a lot on the aftermath, successfully transforming those huge, exhausted mining sites back into thriving natural habitats, turning them into beautiful lakes, public parks, and protected wildlife reserves. But here is a major modern disruption, and it's a real game changer for the future of the industry. Because of the massive cost and effort of mining, scientists have actually perfected the ability to grow diamonds right in a laboratory. These lab-grown diamonds are chemically, physically, and optically identical to mine diamonds. They offer the exact same beauty, the exact same shine, but completely without the need for mining. This makes them significantly cheaper to produce, and a lot of younger buyers are flocking to these affordable alternatives. However, natural gems stubbornly retain their premium price. Why? Because people still assign incredible value to their ancient, millions-of-years-old legacy. For a lot of folks, it's like holding a physical message from deep within our planet.
It really is quite poetic when you think about what a natural diamond represents. A simple carbon particle endures unimaginable pressure and millions of years of silence to become a precious gem. An ordinary particle of carbon sits in total darkness for millions, sometimes billions of years, slowly transforming. Then, powerful volcanic blasts carry it up. Human beings pull off incredibly dangerous and massive engineering feats just to find it, cut it, and polish it. Time, science, immense pressure, and pure luck all have to align perfectly to create this gemstone.
So I want to leave you with this thought today. As technology perfectly mimics nature, giving us flawless lab-grown diamonds at a fraction of the cost, what is it that we are truly valuing when we hold a natural diamond? Is it really just the sparkle catching the light, or is it that profound million-year journey through the deep earth that makes it truly priceless?